Welcome back, Fetchers of America, to Brother Rich TV. Well, usually at the beginning of class, we spend some time answering your questions. And I just encourage all of you, I'm trying to do more examples at the beginning and throughout the lecture so that you have less questions. And we are going to go over a lot today in section 5.2. But before we get started, and I do want to remind you, please use the tutors, use the chat, get help as needed. And I know a couple of you said, hey, can we do some Zoom? And we'll try to do that. It's a little bit challenging. We're going to try to get that done too, though. But in the meantime, let's make sure we're watching these lectures. I want you, in just a second here, I just want to stop this. And what I want you to do right now is I want you to go back in your notes and rewrite the 5 methods of factoring, okay, and the type of polynomial they're possible on. So you know what, I'm going to do this with you right now just because we've only done it one other time. So let's do this together. And I want you, Nicole, camera girl Nicole, can you see me writing over here?
Yes.
All right, okay. So the methods of factoring, okay, methods, factoring, okay. Our first method is to pull out the common factor. Our second method is grouping. We learned both those last time. Our next one we're going to learn today is the x squared plus bx plus c method, where a equals 1. Our fourth method is ax squared plus bx plus c method, where a does not equal 1. And our fifth and final method is special cases. We talked about being an oncologist. That's the formal name for a cancer doctor. And we're going to get all of the factoring cancer out of every polynomial. And we have to approach this from looking at all 5 of these methods. The type of polynomial, okay, that these methods are possible on. All polynomials could have a common factor. Polynomials with 4 terms could do factoring by grouping. Trinomials could be one of these. And all binomials have the potential to be a special case. Today we're going to be emphasizing method 3 and only method 3. We'll talk about method 4 just ever so briefly. Okay, we're going to put a little star by that. We're going to talk about method 4 ever so briefly at the end today, but just a very, very brief introduction. Okay, please write that down. Have it on a note next to you. I'm going to need to erase it. We're going to need that board space here in a little bit. And I want you guys to be able to reference it regularly. Okay? Pause. Okay, before we teach you this next method, the x squared plus bx plus c method, where a equals 1, I need to teach you about prime numbers. And I also want to teach you about the standard form of a trinomial to degree 2. ax squared plus bx plus c. Okay, so this is what we call the standard form, okay, of a degree 2 polynomial, where a, b, and c equal the coefficients, and you can write while I'm writing right now, these equal the coefficients of the degree 2, 1, and 0 terms, respectively. I don't know if you guys know the word respectively. It's not respectfully, full of respect. Respectively means in that order. So I want you to look at this right now. There are 3 terms. So let's go ahead, drop our pens, drop our pencils. We can take notes a little bit later when you pause the video, stuff like that. That's the nice thing about video world. I want you to look at this trinomial here. Obviously, it's all in the hypothetical range, right? We could have something like 3x squared plus 5x plus 2, okay? Okay, so my question for you is, what does A equal? What does B equal? What does C equal in this trinomial? Nicole, what does A equal?
3.
Yeah! What does B equal?
5.
5, very good. What does C equal?
2.
Very good. So I want you all to see this. Notice that Nicole did not say that A equaled 3x squared. Okay, the x squared is the variable and its degree. A, B, and C are the coefficients. They're the big numbers of the degree 2 term. So A goes with degree 2, B goes with degree 1, and C goes with degree 0. And remember, we've talked about in the past that degree 0 is because this is like if we had x to the 0 there, right? Because x to the 0 would be 1, because the degree is always of the variable, all right? Let's do another one. Let's do another one.
There's a helicopter.
So, Nicole's getting distracted. Like, there's a helicopter outside the window. Yeah, it's World War Z out here. I don't know where you guys are at, but no, I'm just kidding. We're out here in the farms, and we have no idea why there's a helicopter out there. Let's go ahead and do another one here. What if I have x squared minus 2x plus 5, okay? Now, what does a equal? Well, let's just do this. Let's erase these, okay? What does a equal now, Nicole?
1.
1, that's right. There's a 1 there. How about b?
-2.
That's right. Okay, we have to take the negative with it. And c?
5.
5, very good. Okay? So this is really important as we use the trinomial methods of factoring. You notice that we organize them in this ax squared plus bx plus c thing. And so to understand this structure, this could look a little foreign to you. What we're ultimately getting at is, do you know what a, b, and c are? Okay? Next thing I want to talk to you about is prime numbers. Okay? So I'm going to erase this. I hope our erasing works good. I'm noticing the board's staying pretty gummy and black today. We might have to stop occasionally and clean this up, but that's kind of yikey gross. Ugh. All right, sorry about that. Don't know what's up today. All right, so I want to talk to you about a prime number. Do you remember what a prime number is? Again, before we get into this method, we need to understand what a prime number is. A prime number, right, it's a number divisible only by 1 in itself. So really, in essence, its factors equal 1 and itself. No other numbers. Remember, so is 8 a prime number? Nicole, is 8 a prime number? No, she says. No. She was looking at her Instagram account, and Instagram, it's kind of like, Magic 8 Ball. Instagram, is 8 a prime number? No. Anyways, so look at this. Is 8 a prime number? No, because it's divisible by other things. It's divisible by 1, and it's divisible by itself, because all numbers are, but it's also divisible by 2, and it's also divisible by 4, right? This is 8, this is 4, this is 2, this is 1. Those are factors of 8. 8 and 1 are factors, but so are 2 and 4. Where the number 7, is the number 7 a prime number, Nicole?
Yes.
Yes, she says. Magic 8 Ball, yes! Okay, all right, so check it out. 7, yeah, it's just divisible by 1 and itself. All the other numbers in between, and if you remember, we did this like on the very first day of class, back in the R chapter. So one of the things I want you to understand is that if we factor a polynomial, like for instance, if we take this polynomial here, x squared minus 5x plus 6, and I tell you that, first of all, can we divide this by 1? Sure, we can. We can divide it by 1, because it would equal x squared minus 5x plus 6, okay? Could I divide this by itself? Okay, so divided by, let's put divided by in between there. X squared minus 5x plus 6. Of course we could. That would equal 1. Anything divided by itself is 1. But this is what's fascinating. Factoring allows us to break this up. Now remember, if we say these are factors, what's 1 times this? It's it. And what's this times 1? It's itself. And so this always comes back to giving us this original polynomial. What other things, when multiplied together, make the polynomial? Just like what other things, when multiplied together, make 8, 2, and 4? Well, check this out. X minus 2 times x minus 3. Let's multiply this out. X times x will give us x squared. X times negative 3 will give us negative 3x. Negative 2 times x will give us negative 2x. And negative 2 times negative 3 will give us positive 6. And when we combine these, whoa, it's magic. Look at that. These are the same. So these two binomials are factors of the trinomial x squared minus 5x plus 6. And what we're going to learn how to do today is we're going to learn how to use method 3 to come up with this answer really quickly. You're going to like this method. It's one of the easiest. It's most people's favorite because it just really makes less math for you, okay? But please listen. What if a polynomial is only divisible by 1 and only divisible by itself. Just like the number 7, it would be prime. And so what we're going to find here is that if something is unfactorable by all methods, okay, it's prime. And so tonight in your homework, you're going to run into that occasionally. And that's one of the hardest answers to accept, is prime. Because we're human, and it goes back to something I shared with you a long time ago. The hardest question to answer in all of life is, am I right? Am I done? Right? And we said that the Savior is the only one who's ever been able to definitively say, I am done. And his final words were, it is finished. Right? And so when we look at something like this, if we are factoring a polynomial and we can't factor anything out, we really kind of question ourselves like, well, am I stupid? Did I not do this right? Am I not thinking of something? Have I left something out? Because our human nature is such that we're like, I probably made a mistake. So we're going to talk about ones that come up, and the answer is prime today as well. All right, let's pause for a second, take some notes. Ready? Are you ready? All right, let's do this. Okay, method 3. Here we go. There's method 3 in all of its glory. Okay. So it looks a little crazy for you right now. Pause your video in a second and write it. Okay, go ahead and pause. All right, I paused for a moment there. It's kind of like a manopause. Because I'm a man. Because I'm a man and I paused. Funny. Okay. If that offends any of you. Anyways, whatever. So, check it out. Let's take a problem. Let's take that one we just did. X squared minus 5x plus 6. Okay? So the first thing I want you to do is I want you to look at that. What if I wrote that? Okay, let's look at it again. Let's see if I... Ooh, that helped a little maybe. This board is just bad news bear today. Okay? What if we had x squared, okay, plus 6 minus 5x? Okay? So the first thing we need to do is, I told you before, get your chart, your total factoring cancer doctor chart, right? And go through it all, because we got to do that every problem. So we're teaching you each individual method so that you can do the whole chart when you're done. So you know the first method. Check for a common factor. Everyone look at this. Do you have a common factor? You got x, you got no x. Okay? There's no numerical common factor. So no, you don't have a common factor, but you had to check. Because you always have to check, because it's always a potential in every problem. Second thing, can you factor by grouping? Nope, because factor by grouping only works for, that's right, 4 terms, and you have 3 terms. And so as you look at your methods, there's 2 methods, okay? And one is where A equals 1, and the other is where A doesn't equal 1. So everything we're going to be dealing with today is where the coefficient of this term is always 1, okay? So our first step here says, to put the trinomial in x squared plus bx plus c form, and in red it says here, descending order, okay? Is that trinomial in descending order? No, it's not, okay? So let's do it. Let's put it in descending order. Nicole, I'm going to need your help. I'm going to need your help. You're going to have to stop looking at the magic 8 ball for a little bit. Guide me, help me, all right? Okay, so my first term is x squared. What should I put next? Negative 5x. And my last term, what's my last term, Cole?
6.
That's right, we're going to put plus 6. So this is all in descending order. One of the reasons we do this is so we can clearly see A, B, and C. All right? If we leave it in this order, we could think that's B, and that's C. But the reality is that's actually C, because it goes here. And we just got done talking about that. So what's A? Let's go ahead and let's define this, just for kicks and giggles. Nicole, what's A?
1.
1. B.
Negative 5.
C.
6.
Very good. Okay? So everyone, that's what A, B, and C are. You don't need to write that for every problem, but I wanted you to understand this is important to these methods. We are going to need to know what C and B are on every method, and sometimes what A is as well. In this method, it says find C and factor it. So we have found C. We know C equals 6. And it says put it in a chart like this. We're going to have C equals 6 and B equals negative 5. And we're going to make a little chart just like this every time. Every single time. Now, I don't want you to worry about what your book's doing. I want you to worry about what we do in here, okay? It says find C and factor it, okay? So tell me factors of C. Nicole, what are some factors, what are some things when multiplied together make 6?
1 and 6.
Very good, 1 and 6. Okay, what's another one?
2 and 3.
2 and 3, very good. Okay, is there anything else?
No.
So sometimes students say 3 and 2 or 6 and 1. Those are the same factors, they're just in a different order, so nothing different there. But there are actually some other numbers when multiplied together to make 6. Can you guys think of it? Can you think of it, Nicole? Is anybody thinking about negative numbers? Okay, we can't use fractions, we can't use decimals, because those aren't factors. They always have to be integers. They have to be that whole number value, and integers are whole numbers that are negative. What negative things would make positive 6? Can you think? What are they, Nicole?
Negative 1 and negative 6.
Very good. Negative 1 times negative 6 make positive 6. And?
Negative 2 and negative 3.
Negative 2 and negative 3. Awesome. Okay? So those are all the factors of 6. And then it says add the factor pairs. Okay, and this is what I lose students sometimes. Okay, watch this. So if I add the factor pairs, 1 plus 6 makes what, Nicole?
7.
7. Okay, 2 plus 3 makes?
5.
Okay, and so some of you right now, if your mind tends to wander, okay, and you just kind of didn't pay attention for a little bit there, you're like, that doesn't make 7, it makes 6. That makes 6. Yeah, we're not multiplying, okay, Sherlock Holmes? We are adding them right now, okay? So when we multiply these, they make 6. But when we add them, this is what they make, okay? So what's negative 1 and negative 6?
Negative 7.
Negative 7. And what's negative 2 and negative 3?
Negative 5.
Negative 5. And so it says here, we add the factor pairs of C, help me Nicole, to find the magic pair when added equals B. The magic pair. Magia. Yeah? Alright, that's Spanish for magic. Nicole's studying Spanish. She is a Spanish queen right now, okay? So Nicole, what's the magic pair? Which one makes B?
Negative 2 and negative 3.
Woo! Ding, 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 right there. There's the magic pair. So all the other ones, people, all the other ones, they don't matter. Okay, we don't care about those. We're only looking for the magic pair. We're going to talk about them not mattering here in a second. I want you to hold off on that. But here's what's cool. We're ready to put our answer together. We are totally ready to put our answer together. So now, the answer to this, you're going to put a parentheses and a parentheses. And every time, you're going to put X and X here. Okay, and you're looking at this going, what does it say, or Y and Y, or B and B? Okay, we'll talk about that in a second too. X times X makes what, Nicole? What does X times X make?
X squared.
Very good. And our first term in this, remember, if we're going to factor it out, if we multiply it back, it should equal the original problem. X times X makes X squared. Okay? What if this was Y squared? Then this would be Y and Y. And that's what this is talking about. Or what if this was B squared minus 5B plus 6? Then this would be B and B. Okay? So while we put X and X here, what we're saying is these two things when multiplied have to make the first term in the trinomial. And then the magic pair goes into the remaining spots with their accompanying signs. So negative 2 and negative 3 go here and here. And we're done. This is the answer to this problem. Let's multiply it out and see if we did it right. X times X makes, Nicole?
X squared.
X squared. X times negative 3.
Negative 3x.
Negative 3x. Negative 2 times X?
Negative 2x.
Negative 2x. And negative 2 times negative 3 makes?
Positive 6.
Very good. And these two can combine, so we get X squared minus 5X plus 6. Whoa, 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 it's magic. Look at that. You know. They're the same. That's right. They are the same. X squared minus 5x plus 6. X squared minus 5x plus 6. Your answer to this problem right here. Do you have to check your answer? No. I just did that to prove to you. We're doing this right. Okay? All right. That's cool. Looking it over. Let's pause for a second. We all good? We're all back here. Okay. So hopefully you took some notes and you're feeling good about this. I want to show you something interesting. Did we need all of these factors? Nope, we didn't need any of them. We just needed the magic pair. And if you only need the magic pair, then we really could condense these two steps right here, steps 2 and 3. And I want to show you this really quick. Okay, so we're going to put it in a chart, but ultimately, and I always want you to put it in a chart. Don't do this in your head, because there's simple things like, sometimes we could think, well, 2 and 3 make 5, and you're looking for -5, so you pick 2 and 3, but that's wrong. It would be -2 and -3. Or sometimes people will say like -6, and they'll do this, they'll say -6 and 1, because they forget that that makes -6, and if they write it here, they'll get it right. Because they'll say, oh, that makes -5 when you add it together, but they really don't make this. If you don't make a chart and you do it in your head, you're going to make some mistakes with your negatives. So I always want you to make a chart, but I want you to understand that these two steps could be condensed, and you could say, basically, you could say, factor C to find the pair when added equal B. You could condense those two steps into one step and say factor C to find the pair when added equal B. So I want you to watch this. I'm not going to write all of the factors on our remaining problems. So Nicole, have you got the next one ready that we want to do?
Yeah.
All right, go ahead and read that to Brother Rich or your daddy. Go ahead.
Y squared
Y squared
minus 11y
minus 11y
plus 28.
plus 28. All right, fetchers of America. I got to think of some good jokes to tell you. Nicole is a jokester. Yeah? Yeah? All right. You got any good jokes for us, Nicole? You got to be Googling some of these, okay?
I'll look some.
Hey, what is invisible and smells like carrots? Bunny farts. Yeah, thank you. Okay. All right, check it out. Y squared minus 11y plus 28. First thing we do in every problem, we check for a common factor. Did you check it? Y, no Y. There's no numerical common factor, so we move on to the second method. This is all of our methods we have to go through in every problem. Can we factor by grouping? No, because there are not 4 terms. And so we go to method 3, because this number is 1, a equals 1. We can use method 3. If this was 2 right here, we'd have to use method 4. And we haven't learned method 4 yet. That's for next time. Yep. Okay? And then we check this. We go through our steps. Is this in descending order? It is. We do not need to rearrange this. And so we say, indeed, C equals 28 and B equals -11. We cool? Okay? And then we got to find things we multiply together make 28. Now I know 7 and 4 make 28. But when added together, they make positive 11. This is why, whatever you experiment with, I want you to write it down. And then, because we don't need 1 and 28, and we don't need 2 and 14. We don't need all that. Okay? But we do know that -7 and -4, when multiplied together, will make positive 28. When added together, will make -11. All right? And we're done. Yeah, this method is fast. This homework's going to kick butt and take names, brothers and sisters. Okay, so do we put x and x here? Nicole, look up here. This is a y squared. Do we put x and x here?
No.
No, what do we put in these?
Y.
Y and y. That's absolutely right. Okay, so we got to use our brain. Okay, this x and x means we put the variable here that's going to make that first term, but it's going to be y and y. Okay, and then the -7 and the -4 drop down. Now, what if you had written -4 and -7 like that? They would still make -11. So you would have ended up with y minus 4 and y minus 7. Now we have discussed this at length. These two things are the same, okay? Let's prove it one more time. Everybody, what's y times y? Nicole, what's y times y?
Y squared.
That's right, y squared. Y times -4?
-4y.
Very good. -7 times y?
-7y.
Very good. And -7 times -4 is going to make positive
28.
28. Very good, okay? And when we combine the middle terms, we get -11y. So we have y squared minus 11y plus 28. Whoa, it's magic. Look at that, they're the same. Let's multiply these out real quick. Y times y, everyone.
Y squared.
Y squared. Y times -7. -7y. -4 times y. -4y. -4 times -7. Positive 28. Combine these, we get -11y, and we have y squared minus 11y plus 28. We have the exact same thing, because it doesn't matter what order we put the binomials in, they are the same. All right, cool. All right, Nicole, let's do another one. You guys take a quick note on that. Let's do another one. You see how fast this goes. Nicole, what's the next one we want to do?
Are you ready?
I'm ready.
B squared
B squared
plus 5B
plus 5B.
plus 4.
B squared plus 5B plus 4. Okay, I want you guys right now to do this one, okay? We'll go ahead and pause for a second. We're pretending to pause.
No.
We're back. Okay, hopefully you did this problem. All right, the answer to this problem, I'm going to put it at the bottom here. Let's see if you got it right. Okay, it is B plus 4, B plus 1. Or in the other order would work as well. Let's go ahead real quick and do it. Okay, first thing we do is we check for a common fetcher. Do you have one? No. Okay, you don't. Can you factor by grouping? No, because it's not 4 terms. But this is one, so we're going to use method 3 for trinomials. We check to see if it's in descending order. That's the first step. It is in descending order. And then we take this, and we're going to go ahead on this one and say, hey, C equals 4, B equals 5, and we do this. And we start saying, okay, 2 times 2, that makes 4, but when added together it makes 4. I'm going to need 4 and 1. 4 times 1 makes 4, but when added together it makes 5. That's my magic pair. I make a parentheses and a parentheses. What do I put in the middle here? Nothing, right? There's always a binomial times a binomial, okay? Because the opposite of division is multiplication, so the answer's got to be in multiplication because we're dividing our factors out. This is B squared, so this has to be B and B, and then we drop down to 4 and drop down to 1 because that's the magic pair. Look at that, you did it right. Give yourself a woo if you did it right. 1, 2, 3,
Woo!
woo! Okay, we're going to pause for real now, okay? I'll give you a few more to do. All right, my brothers and my sisters, check it out. We are, I want you to do one more example, okay? I want you to do this on your own. Notice that I erased everything off the boards here. You need to, if you need to have the steps by your side, make sure you're checking your notes out on this one. Go ahead and pause for a second and do this. See if you can get it right. Okay, we'll pretend to pause. Pause. Okay, we're back. Okay, check it out. The answer to this is going to be, right, A minus 5 times A minus 2. Okay. Oh, sorry. You know what? This is really dumb. You guys really should shoot me. This is supposed to be D squared. Okay? So if you just paused and did this problem, you're like, Brother Rich, I'm so confused. Yeah, we tricked ya! And we actually messed with your mind. Okay, sorry about that. That was supposed to be D squared minus 7D plus 10. Because if you had an A and a D, yeah, that would kind of be screwed up and you couldn't do the problem. Sorry about that. So we'll pretend to pause again. Okay, hopefully you did the problem. You can pause it for a second, do this, try to get this answer. So let's do this together. Okay, is this in descending order? Yes, it is. Okay, first thing we really need to do, check for a common factor. No other methods are usable. We're using method 3, A equals 1. Okay, and so we're going to take this, yep, C equals 10 and B equals negative 7. Okay, 5 times 2 makes 10. 5 plus 2 makes positive 7. Negative 5 and negative 2, that makes negative, positive 10, but when added together makes negative 7. And then we put a parentheses and a parentheses. D squared, not A squared, makes D and D. Dungeons and Dragons. Okay, nerds of America, stop it. And minus 5 and minus 2. Okay, and we're good to go. Okay, who in here has played D&D, Dungeons and Dragons? Have you ever played this, Nicole? This was like popular when I was like, grade school or junior high, and it's made a comeback. Okay, some of you guys are into this stuff. I have no idea. Just don't go around town with a robe on. They used to do that kind of stuff and pretend
Cosplay.
that. Yeah, cosplay, something like that. Okay, we're cool. All right, Adventures of America, check it out. Hopefully you got that right. We're gonna do some weird ones now, and just to get you prepped, Nicole's about to pause the video for real. We're not gonna do any pretends here, but we're gonna put some up here, and I'm gonna call them weird ones. I want you to really try, after I put them up on the board, I want you to really try to do them, okay? And I want you to just follow the steps, and then we'll come back and I'll do all of them with you. Go ahead and hit pause. Okay, Nicole, camera girl, can we see all 5 of these problems in the camera?
Yes.
Okay, great. Okay, guys, these are some weird ones. And again, I want to remind you of some things. Some things that could come up in these weird ones. We're going to pause here in just a second, let you do these 5, but have your steps by you so you can do them. Make sure you've got it in descending order. Sometimes that's the problem, okay? Remember that A must equal 1, okay? That's another thing that might come up sometimes. And also remember all of your methods combined, right? That you have to approach this like a cancer doctor. Sometimes when there's not a common factor, you start getting lulled to sleep and you stop checking for it, okay? Patients die when we don't check them thoroughly, right? And so we need to make sure that we're always looking at all of our methods on every problem and checking those off, because there might be a common factor in some of these. Okay, those are my hints for you. Go ahead and spend a little time on these, and then we'll show you how to do them. Let's pause. Okay, we're back. Let's take the first one, c to the fourth plus c squared minus 56, okay? We check for a common factor. There's not one. We cannot factor by grouping. It is in descending order, but some people are like, well, there wasn't a square term in there. That's okay. C equals, not c the variable, but c the coefficient equals negative 56, and b equals 1. That's right, okay? 7 times 8 makes 56. 7 times negative 8 will make negative 56, but when added together would make negative 1. So we need negative 7 and positive 8. That would make negative 56, but when added together would make 1. Then we can make our parentheses and our parentheses. Nicole, can you see all this in the camera? Are we good on our angle here?
Yeah.
Great. Okay. Here was the thing that was weird about this one. Okay. This and this cannot be c and c. They have to be c squared and c squared, because when we multiply these two things have to make the original term, right? Because remember, when we multiply it out, it's got to equal the original. And then negative 7 and positive 8 would drop down. So the same process, okay? But instead of a and a, or x and x, or c and c, this has to be c squared and c squared, okay? Let's do this next one, okay? First thing we check for is a common factor. And there is a common factor here. What is the common factor? Can you see it? It's x, that's right. And so the first thing we have to do in this problem is we have to divide this by x, divide this by x, divide this by x, and then we get x squared minus 7x minus 60, all right? That was a big deal. If you didn't get that x out, this became a really heinous problem that you couldn't do, okay? So again, the first method of factoring, but we're not done. We have a trinomial in here, and a equals 1 right now, and so we're going to say, yep, that's in descending order. C equals negative 60, B equals negative 7, okay? Two things when multiplied together make 60. Well, I know 10 and 6 make 60. What about things when multiplied together, when added together, 10 and 6 make, what do they make? They make 16, and we need it to make negative 7. There are other things when multiplied together that make negative 60. Can you think about what they are? Okay, let's go ahead and pause for just a second. Go ahead, Nicole. All right, did you think about some other things? Okay, so 12 and 5, if you remembered your times tables, indeed, 12 and 5 make 60. I need this to be negative, so one of these is going to have to be negative. So we're going to pick negative 12, because negative 12 and 5, when multiplied together, will make negative 60, but when added together, they will yield the magic pair that makes negative 7. Very good. Now I want to show you something I did a long time ago. I draw an arrow down here and I put that x right there because that is part of the answer. Then I'm going to have a parentheses and a parentheses. Okay? My x squared here, right, that's going to be x and x that makes that x squared. When we multiply them all together, we'll get x to the third, the original problem. Okay, the magic pair drops down, negative 12 and positive 5, and you're done. That's cool. If you want to multiply these out, check all your answers, you can totally do that. Let's go to the next one. Okay? First thing we do, we check for a common factor. We do not have one. W, but no W. No numerical common factor. And we can't factor by grouping, but we can use the trinomial method. And our square term is the a equals 1. The coefficient is 1, so we can use method 3. But this is not in descending order, so we need to rearrange this. Call it w squared minus 3w and plus 11. C equals 11, b equals negative 3. And so we can say, yeah, what things when multiplied together make 11 when added together make negative 3? Well, folks, 11 is a prime number, and the only things when multiplied together make 11 are 1 times 11 and negative 1 and negative 11, which would make 12 and negative 12. And so this one is Prime. It is prime. That's a hard one to come up with. If you got that right, say woo. I want you to do it right there in your bedroom, your living room, wherever the fetch you may be. Say woo. 1, 2, 3. Woo! I got it right. I hope you got it right. Okay? These are challenging to come up with prime. Can I give you a little hint? Okay? Often. Okay? Not always, but often. Okay? If that last number right there is prime, then this is going to be prime. Okay? And so that's a good way to detect that. Okay? That's a little detective move that you can make when doing these problems. We come back to this, that's not prime, okay, 60 is not prime, okay, 45 is not prime, 72 is not prime, so these are probably not going to be prime. But they could be. They could be. I am going to tell you that, it is not a guarantee that something's unfactorable. But if this is a prime number, then it has the potential to be prime. Okay? All right. Cool. Let's do the next one. This one's really weird. I didn't expect you to get this one right. We check for a common factor. Okay, x, no numerical common factor. So we put this in descending order, negative x squared plus 4x plus 45. Okay, that's what we do. Okay, again, a negative x squared, positive 4x, positive 4x, positive 45, positive 45. These two things are the same. Now, here's the deal. For this method to work, the method is called the A equals 1 method. What does A equal right now? Nicole, what does A equal right now?
-1.
That's right. Not 1, but -1. And so it won't work. So you have to factor out a -1, like a common factor. So we're going to divide this by -1, this by -1, this by -1. You're going to get -1, because we always put the common factor outside the parentheses, times x squared minus 4x minus 45. And then that's going to come along for the ride and be part of the answer, just like we dropped this common factor down. And so you look in the back of the book to problems like this, and yeah, and by the way, all these are from your homework exercises. Okay, I didn't number them this time. I'm just putting them up here, and you can find them, and some of them are odds, most of them are evens for extra credit, but I just want you to do these on your own in the homework tonight. You can fly through this. It's pretty straightforward assignments. Check it out. C equals -45, B equals -4, okay? Things when multiplied together make -45, when added together make -4, okay? 9 and 5 make 45. -9 and +5 make -45. When added together, make -4. I'm going to put a parentheses and a parentheses here. I need this to be x squared, so this is x and x. If it was b squared, it'd be b and b. If it was b to the 4th, it'd be b squared, like the first one we did down there, right? Or the c squared. Okay? Then we drop down the -9, and we drop down the +5. We talked about this if you had your 5 here and your -9 here, you get that +5, -9 there. It wouldn't make any difference. That is your answer. Now, you'll notice in the back of the book, on these ones you have to pull out a -1, they give you multiple options. I want you to know, though, the first option they give is always this, with the -1 on the outside. And that will be the option on a multiple choice test. So you stick with that, okay? That's a great way to do that problem. Last one. This one was pretty straightforward, but it was not in descending order. So you check for a common factor, don't have one, okay? We jump in here, we need to say this is x squared plus 6x minus 72, okay? C equals -72, B equals +6, okay? Okay, 12 and 6 make 72. 12 and -6 make -72. When added together, will make +6. You'll note that if you just did 12 and 6, that would make 18, okay? If you did -12 and 6, that would make -6, okay? So this was the magic pair right here. Don't take for granted writing out all of your options sometimes. I haven't been doing that a lot on here, and I wanted to just show you how important that becomes, okay? If you know 12 and 6 make 72, that's a good start, but 12 and 6 when added together make 18. We need one of, and by the way, that doesn't make -72 when you add it together, okay? It needs to be -72, so one of them needed to be negative. There's your magic pair right there, okay? We put a parentheses and a parentheses. We have x and x that makes x squared, and we have a +12 and -6, and we're done. We're going to pause for a minute, give you a couple more, and wrap this up. Welcome back. Last 3 problems today, all right? Actually, you know what? If Nicole finds a good fraction problem in here, one that has fractions in it, go ahead and find that and read it to me. There's the lovely Nicole. Okay? So I'm going to give you another moment to pause here, and I want you to try these 3 problems. They bring up some weird variations again. A lot of this method is super straightforward, but again, you've got a decimal in here. You've got one here that's got multiple variables. And you got one here where a does not equal 1, okay? So I want you to look these over. I'm not going to give you any more hints. Look them all over. Nicole, did you find one of the fractions?
No fraction.
No? How about on this first page here where they just have like a fraction something like that. Go ahead and read one with fractions to me.
X squared minus 2/5 x plus 1/25.
Okay, cool. Why don't you try this one too, folks, because you're going to do these in the homework tonight, and then you're going to be mad at me if I don't go over one with you. Okay, so we're going to pretend pause. Okay, we're back. Okay, cool. All right. First one, this one right here. Did you get it right? I hope you did. It has a common factor. What's the common factor? Can you see what the common factor is? They're all divisible by, Nicole?
2.
2? Okay, very good. I love that Nicole said 2. They are all even numbers, and they're all divisible by 2. Now, if we divide this by 2, and we divide this by 2, and we divide this by 2, we're going to end up with 2x squared plus 20x plus 50 with a 2 outside of it. Do they still have a common factor? What is that common factor?
2.
It's also 2. Okay? So if you don't get the common factor right to begin with, let me tell you, you can divide this by 2, and this by 2, and this by 2. You can put another 2 out there, and 2 times 2 makes
4.
4, and you get x squared plus 10x plus 25. Okay, are there any common factors now?
No.
No. Okay, so we've pulled all the common factors out. Could we have decided that the common factor in the beginning was 4? Totally. And it would have saved us some work, but it's not a big deal if you don't get the greatest common factor all at once, okay? Nicole, just double check, make sure we're getting all this in the camera angle here. I don't want to lose anything for anybody, okay? So now this comes along for the ride, okay? And C equals 25, and B equals 10. And hey folks, 5 times 5 makes 25, and 5 plus 5 makes 10. And we're going to say, whoop, whoop. 4 is our common factor. X and X makes X squared plus 5 plus 5. Now another way that this answer can be written in a test or in the back of the book, they can put those together and say that's X plus 5 quantity squared. Both of those are the same answer, okay? I need you to understand that, okay? You say, well, which one are they going to write on a test? I can't tell you. It could be either one, and I need you to know that these answers are the same, okay? We cool with that? All right, we all good, Nicole, camera angle-wise? Okay. Okay, this one right here, these two right here, okay, when we start getting into decimals and into fractions, sometimes you guys get real concerned and uptight and stuff. I think I want you to remember what decimals is, okay? Pretend there are no decimals, okay? We just did this recently in the previous section. Pretend there are no decimals, and this is just 2 and 8, okay? Let's think about that for just a second. So if this is in descending order, and it is, we're saying C equals negative 0.08 and B equals negative 0.2. But imagine if this was 8 and 2. Don't 4 and 2 make 8? Yes. And don't negative 4 and negative 2 make negative 8? Yes, because this needs to be negative. And when added together, make negative 2. Okay, now think about this. What if, okay, we had 0.4 and 0.2? So we go to this one right here, because this is going to need to be 0.2. If we take negative 4 and 0.2, it makes negative 0.2. And you can say, Brother Rich, you're the math teacher. You're figuring this out too fast for me. Okay, let's slow down for just a second. Let me explain this one more time. Pretend that the decimals don't exist, that you have 8 and you have 2, right? And you know 4 and 2 would make 8. Remember, this is a negative 8, and that's a negative 2. Okay, and so we have negative 4 and positive 2 make negative 8. When added together, do make negative 2. So that's cool. But the middle term has a single decimal, and so these have to have single decimals to make this. And that's where I plugged those single decimals in there. So we can go point and point, and this is, you know, going to all work out. Well, check it out. Okay? Check it out. Check it out. Okay? When we add these two together, we get this. When we multiply these, do it on a calculator, you're going to find it makes 0.08 because 2 decimals add 2 decimal, or make 2 decimal places when we multiply. And so we can take this and say, indeed, y and y, okay, and negative 0.4 and positive 0.2, and that'll be our final answer, okay? Fractions, okay, check it out. Similar concept, but what I want you to do is I want you to just focus on the denominators, okay? And that's what we did in method 2, okay? We aren't ready to do that quite yet. Let's say C equals positive 1/25. B equals negative 2/5. Sorry, getting ahead of myself here. Okay? All right, so if we look at the denominators, okay, 25 and 5, all right, if we look at this for just a second, 1/5 times 1/5 would make 1/25. Do you agree? Yeah, totally. Now, I need this to be negative when I add together. So if I have negative 1/5 and negative 1/5, sorry, let's put the negative there. When added together, that will make negative 2/5. Very cool. But when multiplied together, this will make positive 1/25. So we can come here and say, yep, x minus 1/5, x minus 1/5. Another way to write that, can you see the bottom of the board here, Nicole?
Yes.
Okay, this would be x minus 1/5 quantity squared, okay? All right, this last one, I really want you to give this a try without me, okay? So if you have it, make sure to pause and do it, but we're going to do it right now. So we check for a common factor. Look up here. P, P, no P. Q, Q, no Q. Okay, so it was close. It looked like there might have been a common factor. There wasn't. Okay, C equals negative 10. B equals positive 3. Okay. 5 times 2 makes 10. 5 times negative 2 makes negative 10. 5 and negative 2 make positive 3. Parentheses, parentheses. Now here's the deal. Here's the clincher where you have to do something you've never done before. P and P make P squared, but you have a second variable down there at the end. Look at that, okay? Let's circle that in red. You have a second variable, Q squared, and you don't have a single variable in the middle. So we have to write down here Q and Q to make Q squared. Now the magic pair still comes in here, plus 5 and minus 2. Now I want to multiply these. I want Nicole to help us out here. Nicole, what does P times P make? Because we got to check, see if we're doing this right. P times P makes what?
P squared.
P squared. P times negative 2 makes negative 2 PQs.
Q.
5 times QP. Will we write QP or PQ?
PQ.
That's right, because we got to have like terms. So we'll have plus 5 PQ. And then 5q times negative 2q will make negative 10q squared. These two combined, we get p squared plus 3pq's minus 10q squared. Whoa, 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 it's magic! Yep, you know it. This and this are the same. So the thing you had to do different here was you had to put the q in the q there, all right? You have some that have multiple variables. You have one on the test like this, okay? I'm going to tell you, I don't think you have any fraction and decimal ones on the test, but understanding how to do that is important. I want to take a minute before we wrap up today. Tell you a couple of things. One, we did a ton of examples today. And again, usually in the beginning of class, we go over your questions, but what we're trying to do in the lectures here are do a lot more examples so that you can handle the homework. And then if you need extra help, you go to the tutoring online or the chat online and you get that extra help. So one of the things that I want to talk to you about before we end today's lecture is we're asking you to do this assignment, but we're going to ask you to do 2 additional problems from the next section. Let's have Nicole pause for just a second. Okay, so tonight's homework, you're going to be doing some odd problems in section 5.2. I always say tonight, really, who knows when you do it, right? But you're also going to be asked to do these 2 problems. These 2 problems right here. And you're going to be asked to factor them. I want you to look at these 2 problems and notice something different. In section 5.2, we're going to be doing problems like this. This is what we just learned today. Okay? I want to ask everyone, including Nicole, what does A equal in this problem? What does A equal?
1.
Yeah, A equals 1. Okay? What does A equal in this problem?
4.
Okay, so A doesn't equal 1. Okay, it equals 4. And what does A equal here?
18.
And so A does not equal 1. Notice that on your overall chart for factoring, that this falls under method 3, but these 2 fall under method number 4. We haven't learned method 4 yet. This is really important, and it's part of your assignment tonight. I want you to wrestle with these 2 and see if you can come up with some viable answers. And this is going to begin our discussion next time, okay? And I really, really want you to understand this, this concept. You have to have a little bit of trial and error on your own before I can teach you the next method. If I just go and teach you the next method next time, you're going to be frustrated. If you do these two problems on your own, you're going to be frustrated. Okay? I need you to be frustrated on your own so that when I teach you, we have a good experience. Okay? So either way, you have to have frustration. So what I'm telling you is it's better for you to be frustrated trying to wrestle with these on your own, and then I teach you the next method. But you're going to have to do this. This is part of your assignment. So how do you show your work on something that you're probably going to get wrong and struggle with? Just whatever work you do, put it on your paper, take a picture of that and send it in, and you'll get credit for these two problems. The last thing I'll tell you, if A doesn't equal 1, sometimes we can make A equal 1 by factoring out a common factor. We saw that in one of our last examples over here on the left board that we did, where we had a common factor of 4, but Nicole helped us see that we could pull out 2 and then pull out 2, and eventually A did equal 1. But you'll notice here, there's not a common factor in either of these, so A will never equal 1, and we're going to have to do something. Good luck, Fetchers of America. We'll see you next time. Go ahead, Nicole.